Yes, good afternoon to you all once again. We have spoken about differentiation 1, that's the calculus, where we dealt with the limits. And now we are moving to the differentiation from first principles. Differentiation from first principles. And we established that if I have, let's say, we used a Pascal triangle and explained to you that if I have 1, 1, 1 like this. Okay, that's how we started it. And I said that you add this to this, you get what? 2. The n here should be 1, n here should be 1. I'm building some triangle which I'm going to use for certain expansion. Then I told you that here, I add this, I get what? 3, 3, 1, 1. Okay? The next triangle will be what? This part, this is what? 4, 6, 4, 1, 1. I can use it to build as such. Here, this part is what? 5, 10, 10, 5, 1, 1. You see that it's in the form of a triangle. That's why we call it the Pascal triangle. Okay. So, and I said that if I have, let's say, what do I even put there? But let's say x plus h to the power 3. How do I expand this? In this case, you can see that the power here is what? Is 3. If the power here is 3, I'm going to use it for a purpose. That's why I'm taking my time to explain this, okay? If the power here is 3, then I'm going to pick coefficients that are what? 4. If the power is 5, I have to pick coefficients that are what? 6, and so on and so forth. Let's see how this one is expanded. The moment we get this, then we are through. So here, I said that, so the first coefficient is what? We have 1, okay? Then I pick this x, then I bring this 3, plus, next coefficient is what? It's 3. We are using this one, it's 3. Remember that this is x3, h0. So h0 is the same as 1, that's why we didn't write it. So x3, h0. So as x decreases, h increases. So here, I write my 3, x2, x reducing, then h move to what? 1. Okay? Still, next one is what? It's 3, x1, h2. Okay? Then plus 1, x0, h3, x0, h3. So you can see that when we have the 0 power, it's the same as 1. So here it becomes what? S cubed plus 3x squared h. Then plus 3x h squared plus h cubed, because this one will be 1. If you expand it, this is what you are going to get. So look at how the expansion has been done, so that when I start, you get it straight with me, okay? Hope you're okay. Look at the way I did this expansion. Don't tell me that this is what? Is x3 plus h3, as many students do. This is wrong. This is not equal to that. This is the real expansion. So, let us move on. So, from differentiation from first principle, we said we have to differentiate what? Y is equal to x from first what? Principles. There is a formula that we normally go by. Yes, I'm repeating that. I've explained to you how to expand a specific expression. So if I have, I told you that if I have 1 here, yes, what? 1, 2, 1, 1, 3, 3, 1. Okay? And I told you how to build this Pascal triangle. Now, if I have an expression like this, and we are asked to differentiate from first principles, y is equal to x, then this is how it goes. We are going to have, so if you let this one be x, okay, and we are having variety of them, so I'm trying to pick them one after the other, and we follow it as such. So in this case, you say that dy dx, I'm just quoting this so that we will not, is equal to limit as h approaches 0. I'm quoting the formula, then we move from there, okay? So here, I'm going to have f x plus h minus fx all over h. Don't let this one be actually beat your mind. We are considering the original expression as well as fx is equal to y is equal to that. So if you happen to get this, then you say that the limit as h approaches 0, because we've already spoken to you about limits. So I want us to look at typical example, okay? But this is just the interface. You have to look at it from that. So let's see. You say that differentiate from first principles expression y is equal to x squared. We are differentiating from first principle. You know, if it were to be the ordinary way, we would have said that it was 2x, then we are done. But here it's not going that way. Look here. So over here, what we are going to do is that we are going to expand this. So we say that the limit as h approaches 0. This is what we are going to have. We are going to have x plus h, watch here, squared. Okay. That means all that we are saying is that whenever you see the x, you add h to it. Okay. Then minus the original x, which is x squared, all over h. This is what we are talking about. I'm repeating. If you see y, we are going to have about 3 of this, and definitely you'll be getting it. I'm saying that this is x squared. So you write this x, then plus h. Then instead of writing this x like this, the first part, you write the x, you attach h to it. Then because the square, you bring square there, then minus the original expression, this one, all over the h. So as I told you, per our expansion that we did, we have what? When you expand this by the Pascal triangle, this one I told you, we are going to have x squared, okay, plus 2xh, you can try it and see. Then plus what? H squared. Then minus the original x squared, all over what? H. Okay? So over here, this will cancel this. And we are left with the limit, okay? The limit, the end of this one, where this line was actually drawn, I think it's somewhere here, right? Let's check it for me. Okay, sure. So the limit as h approaches 0, what are we having? We have what? 2xh plus h squared all over h. Look at here. So the h cancels h here. Then what I'm trying to say, I'm having 2xh over h plus h squared also over what? H. So h will cancel h here. And we are left with what? 2x plus this one will go into it, what? H. Okay. Then we say that the limit as h approaches 0, h will approach 0. So dy dx is equal to what? 2x. Dy dx is equal to 2x. I'm going back again. We have been asked to differentiate this x squared. So what you are going to do is that you are going to write this x squared. Then after writing the x squared, look at the x squared. X here in the square there. Just add h to it. So it becomes x plus h. Okay, before the square comes. That's inside this one. Minus the original x squared, which doesn't involve the h. And involve the h. And this is what you're having all over the capital H. After working everything, then you divide through by the h. After you do your cancellation, whenever you see h, then that expression goes to 0. So this is what you are having. I think we have to look at another example, okay? Let's look at another example. We are on differentiation from first principles. Is that okay? Differentiation from first what? A principle. So let me see if I'll be able to get another example that will help us. So you say if y is equal to 7x, we should differentiate this from first principle. So note that we let what? Fx be equal to what? Your 7x. I'm repeating. The original thing is the fx now. Fx. So over here, we say that limits as h approaches what? 0. What do we have? We have 7 x plus h. That's wherever you see x, we attach this to it. Okay? Minus the original fx, which is what? 7x all over h. So if I open the bracket, I'm going to get what? 7x plus 7h. I'm opening the bracket. Minus 7x all over h. So 7x minus 7x will go. Then h will cancel h. So you say that the limit, say dy dx is equal to what? 7. dy dx is equal to what? 7. And you can try it. You can, if you use the ordinary way that we went through, that's what you're going to get. Okay. Now let's look at another one. Let's look at another one. If I have y is equal to 3, okay, 4x squared, okay, plus x minus 1. And we are asked to differentiate this from first principles. Then we say that the limit as h approaches 0, we have 4, then here is what? X, watch here. So wherever you see x, x plus what? H squared here. Plus another x plus what? H also here. Minus 1, like this. Okay. All minus the original expression is what? 4x squared plus x minus 1. All over what? H. So here we are going to have 4. Don't open the bracket straight to 4, and here is what? X squared plus 2xh plus h squared. I'm repeating, I'm expanding this. So the x is, the 4 is outside. Then plus x plus h minus 1. Okay. Plus x minus h plus 1. Let me clean here so that it will look very straight away to you. We have been asked to differentiate this from first principles, this very expression. And look at what I'm doing. Anywhere you see x, you put it in bracket and then you attach h to it. So here, since we have x, you say x plus h, the 4 is here. Then plus, there's another x here, which is also x plus what? H. Then minus 1. Okay. After that, then minus the original expression, which doesn't involve the h. And that is what? 4x squared plus x minus 1 all over h. Now let's see. So we have to know how to expand this one. And this is what we have expanded. Be very careful not to multiply this 4 by the x straight away. That's not the time. We have to expand this first. Okay. So this is where we are. So this is that, minus 1. Before minus what? 4x squared. This minus is affecting the, here is also what? Minus x. Then here becomes what? Plus 1. All over what? H. So now let's open the bracket. Here becomes what? 4x squared. Okay. Plus 8xh. Plus 4h squared. Plus x plus h. Minus 1. Minus 4x squared. Minus x plus 1. All over h. That's the limit as h approaches what? 0. Now watch here. Interestingly, where the challenge is when I tell you, make sure that when you're opening the bracket, the negative is going to affect these ones and their signs are going to change. That is why here, the 4x squared has now become negative 4x. The x here has become negative x. And then the negative 1 here has become positive 1. Exactly. Now let's see. You see that some of them will cancel themselves. 4x squared will cancel negative 4x squared. Like this, okay? Then x will also what? Cancel negative x. Is that right? Then negative 1 will cancel positive 1. So in the nutshell, we are left with here, we are left with what? 8xh plus 4h squared. Okay? Then plus what? Plus h. Plus h. All over big H. This is the limit. Exactly. This is the limit. So I can move to this side. Alright? Okay, good. So here I'm going to have what? Limit as h approaches 0. We are going to have what? 8xh over h plus 4h squared over h plus h over h. Okay? So the h will cancel h here. We have what? 8x plus 4h plus 1. And the limit as h approaches 0, this one will approach 0. So we are having what? 8x plus 1. That's our dy dx. Dy dx is equal to this. Now let's check and see whether that one is really true. Okay. Let's check and see. What is the original expression? You could see that if you differentiate it, you are going to get 8x plus h. Plus what? Plus 1. This one will go to 0, so which is very, very true. Exactly. Somebody will say no, true. Okay, sure. We are on differentiation from what? From first principles. Okay, differentiation from first principles. So let us see if I'll be able to get another sort of differentiation that we can also be talking about. I'm trying to comb through to see another typical example so that we can move on and on and on. It seems I captured one. Okay. Now let me see. There was one interesting. Okay. Now you said we have to differentiate. If I have fx is equal to root what? X. We are supposed to differentiate this from first principles. So we say that limits as h approaches 0, we have what's the original expression? Root what? X plus h. Okay. Yes, root x plus h plus what? Minus root x like this. All over what? All over h. Now here we shall move a little bit into sets. So, you know, by principle of difference of two squares, we can multiply this, we can rationalize by multiplying this by something. So here, if you have a little knowledge about the set, then you're going to have x plus what? H minus root x like this. Okay. Multiply by the same thing, but this time, is it a conjugate, whatever it is. You have to produce this one. Here becomes x plus h plus root x. This is it. So that becomes difference of two squares. Exactly. All over x plus h plus root x. This is what we are having now. Okay. All over what? H, that like this. So here, the top is going to give you difference of two squares. So the top is going to be this one. The square of this will be what? X plus h. Yes, minus x. All over root what? X plus h plus root x. this is still what? The limits as h approaches what? 0. Okay. So, and this will go off. So right now, where are we and what are we having? Right now, I'm having 1 over h, which is divided by h. Then here is h over root x plus h plus root x. This h will cancel this and we're left with 1. So with this limit, I'm having 1 over x plus h plus root x. Now, so we say that the limits as h approaches 0, then this h will go to 0. So we are left with 1 over root x plus root x, which is equal to 1 over 2 root x. 1 over 2 root x is the answer. I know this one is a little bit complex because of the set, application of set involving. So that is how it is. So you can go more about the differentiation from first principles and then be getting it right. Okay. If not, okay, let me solve last one under this. Then from there, then you can move to different level. Are we okay? We have differentiation from first what? Principles. Differentiation from what? First principles. I'm trying to get one other example, then we solve. Then from there, straight from there, we can actually proceed. Okay. I think there is another one here. There's another one here. We said you have to differentiate from first principles. Fx is equal to 1 over x. So in this case, as we are saying, the limits as h approaches 0, what are we having? We are having 1 over x plus h, as we said, okay, minus the original, which is 1 over x. All right, this is what we are having now. So times, if I do this, it means divided by h is the same thing. So what do? This is what we are having. So I can decide to write this in a simplified way. So here is what? X plus h. I'm finding LCM for here. I'm finding LCM for this. What is inside this bracket? Exactly. So here, this one goes into this what? X. This one cancels, so it will be x. Minus, what happens? Then x goes into this by what? X plus h. Exactly. 1 over h. I know it's a little bit challenging, but you have to try and then follow. So over here, if I open the bracket, still under the limits, as h approaches what? 0, I have x minus h all over x x plus h like this. 1 over h. Well, 1 over h means you are dividing. So this and this will go off. Okay? And this h will cancel this and becomes a negative 1. So we are having negative 1 over x plus h. This is what you are having. So we say that the limits as h approaches 0, this one will go to 0. We are having 1 over s squared, negative 1 over s squared, and that is it, negative 1 over s squared. So we have differentiated it that way, exactly. Now, so from differentiation from the first principles, you can. I'm writing one down, and you have to try your hands on. When you finish, you can cross-check your answer with. Let me see if I'll be able to get. Try your hands on this one. Try your hands on this one. We have x, fx, okay, is equal to 4x cubed plus 5. You know that if you use the ordinary method, it would have been what? 12x squared. It would have been 12x squared. So use differentiation from first principle by expanding this, go through the process and see. After you finish, you can use the first method to check whether everything is on course. You can check it yourself. Is that okay? So that is how. So that's about differentiation from first principles. You have variety of them that you can, try yourself and be getting it. So I strongly believe that the limit for this side, it is very okay. As we said, limit for this side, is it okay? Sure, okay. All to the end. Okay, sure. So I've been giving the signal by my manager about it. So we have to move on. Let me remind you again that we are talking about a company which is what? The Forever Construction and Consultancies Limited. I've already spoken about the activities. That is, they sell land, which is not having any litigation on them. And then also the Action Senior High School, the secondary school that you can trust. Action Senior High School, they have a lot of competent teachers that will be helping you. They are at Medina in Accra. That is Medina, around Atomic Junction. When you ask of Action Senior High School, you'll be able to get it. If you're in SHS 1 or 2, or you want to do remedials, you can go there and you pass once and for all. They have very, very good and competent teachers that will be helping you. That's the Action Senior High School, a powerful senior high school indeed, which has produced a lot of elite, a lot of dynamic doctors and others. So you can call Action Senior High School and enroll for your work, whether you are in any other country. So we have a lot of examiners, foreigners over there, and then people who can actually be helping you. So call Action on 0544 09 99 58 or 020 89 85 488. Go there and enroll, and you pass once and for all. Action tops all. That's it. I'm continuing to remind you that Forever Construction and Consultancies Limited, who are selling land, litigation-free lands that are located very well with very good demarcated roads and others. We talk about the road network. You have the facilities, the utilities available over there that will be helping you around Dodowa. They have land there. We have OEB and several places, including in Sawomen and Utubreku. All these places, they have a lot of lands there. You are protected because when you do it, their documentation is going to the documentation that they are going to assist you in the documentation. Please call Forever Construction and Consultancies Limited. They are a company that's actually supporting what we are doing very much, and we are very grateful for their assistance. So their number is 050 Forever Construction and Consultants Limited. So if you are outside the country, if you are outside Ghana, and you want to build special homes so that when you come back, your uncle or whoever will not chop your money or something of that sort, then of course you can call them directly on these numbers. They will help you. They can build the home for you when you come, the special house. When you come, you can comfortably and then get relaxed until you go back to your wherever you are staying. You are living for. You are living. So their lands are very good in the fast developing areas, especially the one at Pram is close to the what they call the Central University, and all those places you can be getting them. So call Forever Construction and Consultancies Limited on 055 48 92 143 055 48 92 143. I have been advertising them on the traditional television on several occasions and radio stations. So this is not the first time I'm talking about Forever Construction, and people who have actually bought their lands are testifying that there are certain people, when you buy land from them, before you realize it is something else. But for them, when you buy it, you are safe because their documentation and everything is intact. So now that I've spoken about the differentiation from first principles, I think we are going straight to other areas. Now, there is one differentiation aspect which actually disturbs a lot of students. I don't know. That is differentiation of implicit functions. Implicit functions. Let me get back to you quickly. Differentiation of implicit. So we are now on differentiation of implicit functions. Okay. Differentiation of implicit functions. You know, we have the product rules and others, but all of them, we are treating them so we can be moving like that. Or, okay, as I've already mentioned, let me move on because we shall definitely come back to that. So if I have x squared plus y squared is equal to 0, and we say we should find what? The y, the x. That is, we have to find this. You see that this one is a little bit, if you don't take it, it confuses you because it is an implicit function. Looking at its nature, it is what? An implicit what? Function. So over here, look at what we are going to do. We are going to differentiate them more or less like it's going to be like a partial differential. Okay, don't let it one sound very strange in your ears. But so here, what we're going to do is that here, if I differentiate this separately, I'm going to get what? 2x, and we have already learned that. Okay, plus then we are differentiating this y. What is it? It's going to be what? 2y. But anytime you are differentiating y, attach the y dx to what you are doing. So here what? The y dx to 8 is equal to 0. I'm repeating. This is x, this is y. At a certain point, you see that there will be some partial differential whereby you have to differentiate them separately. I say you differentiate this. I've taught you how to differentiate this, right? And I've taught you how to differentiate this one. The y come here, and then you subtract 1. But when you differentiate y, anytime you differentiate y, you get this result. Attach the y dx to it. Then after that, then you make the y dx the subject. So over here, you see that man tutorial is very straightforward. Please subscribe to Calendar Man TV, and you'll never regret it. Look at the way people are patronizing the 3 sets problem and others. Why are people doing that? Because they've seen that the presentation is going on well for them. This is a total classroom where you can learn and pass. Where this one, it is free. When you get it, you are instead of spending certain time somewhere, you understand it. You are going to write the examination and pass straight away. Is that okay? Now over here, so we have what? 2y dy dx is equal to negative 2x. Is that okay? So if I want dy dx, it's what? So dy dx is equal to negative 2x over 2y. That will be what? 2 cancel to have a negative x over y. This is implicit function. An implicit function that confuses a lot of science students and people. I'm trying to break it down for you to see that yes, really, this is mathematics, and by God's grace, we are making sure that you understand. Is that okay? Sure. Now, I want us to look at another. They say we have to differentiate this one also, and we have x squared plus x y squared minus x minus y. Okay, is equal to 0. This is an implicit function that you are doing what you are differentiating. Now this one is the x standing alone. Yes. So here I'm going to have what? 2x. You remember I've taught you this. Then interestingly, we first differentiate y and x, and you know that there's 1 here. So here 1 will come here. So here, watch here. Here, this 1 will come from there, we subtract 1. So here will become x to the power 0, which will definitely give you what? 1. I'm repeating. If I move this 1 here, if I move this 1 in front, because I'm differentiating with respect to x. If this 1 come here, it becomes 1x, then 1 minus 1. The minus 1 will make it x to the power 0. So the x will vanish, because the x will be the same as 1. So here, I'm going to have y squared because the x has vanished. Okay, then plus what next? This time we are going to differentiate y. So if you are going to differentiate y, then for the y we are going to have what? 2x, okay, y. Then this 1 comes like that. You see that the same thing, one thing, we are differentiating it while we are differentiating the x with respect to x. The x vanished because the x power was just 1. But why did it vanish? Why? Because after the 2 came in front like that, and we have xy, the y you subtracted 1 is still, the y is still having a power 1. Okay? Then you are differentiating x here. Now, but once you are differentiating y at this point, you attach the y, the x, minus, you are differentiating x, there's no y there. So minus what? 1. Okay? Then here we are differentiating y, so that one to minus 1 dy dx, all is equal to 0. Anytime we are differentiating y, you have to attach dy dx to it. So now look at the dy dx. I have what? 2xy what? dy dx minus 1, that is dy dx. Okay? How many dy dx do we have? There are 2. Okay? It's equal to positive 1, got this one across. So it will be what? 1 minus 2x, okay, minus y squared. Have a look at it. I'm grouping the dy dx here. Those involving dy dx are this and this. All the rest are moving to the other side of the equation. Is that okay? So now this is what we are having. And by factorizing, I'm having dy dx in bracket what? 2xy minus 1 is equal to 1 minus 2x minus y squared. So subsequently, dy dx is equal to 1 minus 2x minus y squared, okay, all over 2xy minus 1. This is implicit functions. It's very interesting, okay? Now, let's see if you'll be able to get another one. There's another one here that we have to differentiate. If you're okay with what we've done here. I'm repeating that anytime you have two variables here like that, you differentiate them separately. You treat x here. The x, if I differentiate x here and the power of x is 1, then when 1 comes here, then you minus 1, the x will become x raised to the power 0. So the x will, that's why the x has vanished. And since you are differentiating with respect to x, the y remains. But the same thing, you have to, this time you differentiate with respect to what? To y. In this case, what is the power for the y? It is 2. So I bring the 2 in front, I maintain the x, then the y is what? The y minus 1. So the y still have power 1. And we are saying that anytime you differentiate something with respect to the y, make sure that you attach the y dx to it. So let's see another interesting example here. That is actually, you know, making our understanding more straightforward, and that is that. Okay. This is Calendarman TV, and I'm charging you to subscribe and then inform your friends. If you have children home, those who are on vacation and others, you can learn this completely. Okay, a lot of information, a lot of tutorials are coming your way. So now let's go. We are moving to what you call the products rule in differentiation. Okay. The product what? If I have y is equal to uv, we shall use typical example, don't worry. Then we say that dy dx is equal to u dv dx plus v du dx. I'm repeating. If I have an expression like this with u, which is having uv means u times v. Anytime you see uv, it means u times not u plus v. So the fact that you don't see anything here doesn't mean there is nothing here. There is what? There is a multiplication here. So without wasting my time, I want us to look at a typical example under the product rules, and then we follow it as such. So he said that if 2x plus 3 over x minus 5, if y is equal to this, find what? Dy dx. Oh, sorry. I've rather used what you call the quotient. Sorry. So if I have this to be what? 2x plus 3, then x minus 5, like this. In fact, u is equal to what? 2x plus 3. I mean the first one is termed as your u. So du dx is equal to, this one goes off, you remember, and here becomes what? 2. Then we are talking about the v. V is equal to what? 1, because this one goes to 0 and this is 1. Okay? Sorry. V is equal to x minus 5. And dv dx is equal to 1. That's what I'm saying. So, dy dx is what? Is u dv dx plus what? Plus v du dx. So what is our u? Our u, the original u is what? 2x plus 3. I'm repeating. Right now, when you are given this, you write this u, then you differentiate it. You write this v, then you differentiate it. Right now, you say that you multiply the u, original u, which is not differentiated, by the differentiated v plus undifferentiated v, the differentiated u. So this is our u, and what is this is our u? What is our dv dx, which is equal to 1, plus v. What is our v? V is x minus 5. Then du dx is equal to what? Is equal to 2. So right now, what are you going to have? This time, this is what? 2x plus 3 plus what? Plus, oh, what is here? Here is 2. So plus 2x minus 10. So what do we have? This and this will be what? 4x, and this will be what? Minus 7. This is your dy dx. This is your dy dx. Is that okay? So that's that. Okay. Now let us see another typical example under the product rule. When you reach those in the level 100, 200, whatever it is, where the across also where the lane, the natural organism come in, this one it will surface again. So let's see another one. If I have, say y is equal to 2x squared plus 3, then 5x plus 8. So here, straight away you see that they are product because it is this and that. So we say that u is equal to what? 2x squared plus 3. Then you differentiate straight away. Du dx will be what? It will be 4. You remember that? 4x. This one goes to 0. Then v is equal to what? 5x plus 8. So dv dx will be equal to what? 5. Right? Therefore, dy dx is equal to u dv dx, okay, plus v du dx. So what is your u? U is the undifferentiated u, and it is 2x squared plus 3. Are you okay? U is the original u here. dv dx is what? Is 5. Plus v is what? 5x plus 8. Du dx. Du dx is what? Is equal to 4x, right? So let us expand and see what will happen. Here becomes 10x squared plus 15. I'm multiplying this. Plus 20x squared plus 32x. Is that okay? So if I add this to this, I get what? 30 what? 30x squared, this and this, plus 32x plus what? 15. This is your dy dx. Is Is that okay? This is your dy dx. Now, let's see if we can talk briefly about the quotient rule. After the quotient rule, then we move on and on and on. Okay? We move on and on and on. I hope you're okay with this one. You see, the point is that just write, if you get this one, just write this. Differentiate it. Write this, which is the thing. Differentiate it. Then after that, you multiply the undifferentiated u by the differentiated thing. Then plus undifferentiated thing times differentiated u. When you sum them up, then you are gone. Okay? You're gone. Okay. Now, let's see the quotient. When we talk of quotient, you know quotient. What a quotient is, more or less like division. If I have y is equal to u over b, then we say that dy dx is equal to, we have v du dx, okay, v du dx minus u dv dx all over v squared. That is the formula. So let's try one example under that, then quickly we can move on. So if we have, I'm using this again, if you have x squared minus 1 all over 2x squared plus 1, find dy dx. I'm repeating. If I have x squared minus 1, then 2x squared plus 1, find dy dx. It means differentiate this. So per our formula and our narration, what are we having? U is equal to what? X squared minus 1. So du dx will be equal to what? 2x, right? Then our v is the one on the down. V is the denominator. U is the numerator, v is the denominator. So v is equal to 2x squared plus 1. Alright? So dv dx is equal to what? 4x. This one will go to 0. And the rule is saying that it's going to be v. What is the v? So dy dx is equal to v, and v is what? V is what? 2x squared plus 1, right? That's your v. V du dx. Du dx is what? Is 2x. Here, instead of plus, you say minus u. What is the u? U is x squared minus 1. The v dx is what? 4x all over v squared. V is what? 2x squared plus 1 squared. Okay. So in a nutshell, if I open the bracket, we say that dy dx becomes what? 4x squared. 4x cubed, sorry. Plus 2x. Minus 4x cubed minus 4x. I'm trying to open the bracket. All over 2x squared plus 1 all squared. So here, I'm going to have what? 4x cubed plus 2x minus 4x cubed plus 4x. Okay, all over 2x squared plus 1 squared. So this and this I think will go off if everything's right. So here becomes what? 6x over 2x squared plus 1 squared. You can decide to expand it, but this is the dy dx that you will have. Exactly. That is how it goes. That's how it goes. So we will be continuing as such. Now that we've captured implicit functions, we've captured this one, we are now moving on and on and on to certain additional information. Let me check. So Where are we going? We are going to where we are supposed to go. Is that okay? Now, wait. Okay. Let's see this. Let's see this. Because something, the chain rule or function of functions, okay? Function of a function within a function. That is what we call the chain rule or function within a function. I'm trying to check one or two of them, but it seems it is a little bit trying to escape me. But nevertheless, I will grab it. Now, the chain rule or function of what? Functions. Okay. We are done with the implicit function, so we are talking about the function of functions. Now, let's see this. If I have y is equal to 2x squared plus 3 squared, like this, then they say find dy dx. Find dy what? Yeah, that's it. Find dy dx. How are you going to find dy dx in this regard? Okay. How are you going to find dy dx in this regard? It seems I'm trying to get one or two of my papers. I don't know. Well, let's continue as such. Okay. Now, here it is a function within a function. So in the solution, we say you let u be what? 2x squared plus 3. That's what is within. You make it what? U. The moment you do that, then we say that the u, the x, you are differentiating, it becomes what? For this one goes to 0. You remember that? We have done this already. The u dx is equal to that. Okay. But since you have put, you have made this one u, then of course, y will be what? Y will be what? Y is equal to u squared. I'm repeating. I have to be very careful here. We are saying that we should let this one be equal to u. So we made this one u and we differentiated. And now u is here. So y is now, here is u, so y is equal to u squared. So the y, the u is equal to what? 2u. Look at it carefully. This is one differential. This is another differential. So when you finish, okay, then we say that dy dx is equal to the u dx times dy du. Now, what is our du dx? The bottom line is that you have to multiply the two differentials. So du dx is what? It's equal to 4x. Then dy dx is what? Is 2u. So it becomes 8xu. But note that we have already stated that u is this. So it becomes 8x, then into bracket 2x squared plus what? Plus 3. Now, we are still on differentiation of function of function, that is the chain rule. So if we have y is equal to 3x plus 2 to the power 3, we should find dy dx. You see that there is a function within this function. So we call that function what? U. So we let u is equal to what? Let u is equal to what? 3x plus 2. That's this one u. Okay. The moment you do that, let me bring this one a little bit so that you get it there. We are saying what is inside is what? U is equal to what? 3x plus 2. And the moment you say here is u, then y is equal to what? U to the power 3. Are you okay? watch here. You are saying let here u be equal to this. So if u is equal to this, then here in place of this one, y is equal, instead of writing this, you write u squared. So we are going to differentiate both of them. After that, they will multiply the product. That's all. So here, du dx is equal to 3. Is that okay? Then we are differentiating u with respect to x. Then dy du is equal to 3 u squared. Is that okay? Then after that, just multiply that. So we say that then dy dx is equal to, you multiply the du dx you got times dy du. In any case, even when you watch, you see that when this cancels, then we have dy over dx. So here, what are we having? What is the du dx? Du dx is what? Is 3. And dy dx is what? 3u squared. Now, if I'm to come in, the reason why I move this way is that sometimes if I go this way, I will cover the writing. That's why I'm moving this way, so that it will be very clear for you to see. So always see the way I'm moving. I move towards this direction, so that you have access to look at what I've written. Exactly. So here becomes what? 9u what squared. And remember that the u, you said u is equal to this. So why don't you put it? So we have 3x plus 2 squared. So if I want to further expand it, then I can say 9. Here will be 9x squared plus, if I expand this is plus 12x plus 4, like this. There's a way of doing this thing. The square of this plus the product of twice this and this, then the square of the last number. So in effect, dy dx is going to be what? 81x squared plus 12 9. 12 times 9 is 12 is 120, so 108. So 108x plus 18, which is what? 36. So that's our dy dx for this value. Exactly. Now let's look at another one. We are talking about the function of a function. So let's see this one. If I have one of them is y is equal to s squared, okay, plus 4 raised to power 5, and we are finding the y dx. What did I say? I said that we let u is equal to what? S squared plus 4. If I put u is equal to s squared plus 4, it means y is now what? U to the power 5, because in place of the, we are saying you should make it to u. Differentiate both of them. So here you differentiate the u. So the u dx is equal to what? 2x. Then dy du. Look at dy du dx. Here becomes what? 5u to the power 4. After that, then your dy dx is equal to you multiply the two differentials, which is 2x 5u what? 4. You can pull the number, it becomes 10x u4. Okay. Then you can now go and put your u back. So it will be 10x. What is your u? What's your u? U is what? S squared plus 4. This is the power 4. And when you expand, you get whatever you want to get. I think that for now, we have to pause a little bit. When we come back, then we will be moving to the calculus tutorial 3. This is tutorial 2. And I'm reminding you that subscribe to Calendar Monty, because more will be coming your way. After this, you know, we have the trigonometry, we have so many topics that will actually be helping you. Integration is there, so many topics, which when you learn from here, at least this one will contribute to your success. Let me say that. Okay, so make here your classroom and it shall be well with you. Subscribe to Calendar Man TV and make sure that you inform other people about what we are doing here. Sure. So that's that.